And one of the ways, let me just tell you a few words only I'm going to have time for, of another project in the TEL program, which is called the Ensemble Project, which is really trying to look at university courses and devise semantic web technologies which will support the student learning. Now, this is one of the ways in which definitely in the next 5 or 10 years we will begin to see some ways of making sense of information and turning it into knowledge. And I know, I've just come from Australia, and I know that there's a huge semantic web initiative taking place in Australia, and I think we will begin to see it spread around the world. Some of these tools that are really available, by the way, I have no idea, I found the graphic on the website of the project, and then I discovered that it's something to do with plant photosynthesis, and I don't know anything about plant photosynthesis, but I can tell you that according to their website, this is drawing in information from 15 other websites automatically, and asking the technology, using semantic web tools, asking the technology not only to represent the data in a way that human beings and other computers can understand, but also to try to make sense as the student progresses and tries to make sense in this way, to make sense of what the student is doing and learning and thinking. So this is a very ambitious project, and it's the kind of project, I think, that we're beginning to see more of. And certainly, if the semantic web becomes a reality, not just a subject of cute articles in magazines, if it becomes a reality, it is one of the ways, I think, in which we will learn how to control information and turn it into knowledge in the future. So I think that turning information into knowledge for different kinds of people, with different kinds of learning styles, with different preferences about the way you prefer information to be displayed. We shouldn't imagine, for example, that everybody would prefer a graphical representation than a table representation of data. We shouldn't imagine that everybody is comfortable with written text when they could have other kinds of representations on the screen. And taking account of those learning preferences has been a concern of the education research community for 50 years now, worrying about different preferences and different dispositions of students. And now is the time when we could really begin to take account of that, because the technology will help us to do it. So that's what productivity is. Affordable and acceptable ways. I think we have to decide together what acceptable means. And I just want to share with you a project which I think is really interesting, that a colleague of mine, she works next door to me in the London Knowledge Lab, and it's called the Learning Design Support Environment. Her name is Professor Diana Lorillard, who some of you may be familiar with. And she's taking hold of this idea of productivity and saying the least supported element of the learning and teaching situation is the teacher. So let's design some tools which are sensitive to the teacher. And she has this nice idea of teachers using a very sophisticated system, about which you will have to find out yourself if you're interested. I don't have time. But using a sophisticated system to try to help the technology in a really beneficial and productive way. So this is a kind of recursive system. It's an intelligent system to help teachers to use digital technologies intelligently. And here is the teacher who, as the learner, uses the system to build, test and share and reflect on a particular choice of learning design. And then the system uses that information to adapt to what the teacher is trying to do. And here is my take on this project. I haven't discussed this with her yet, so it may be that if this is being podcast, she may email me in 5 minutes and tell me that this is really not true at all. But here's my take on this project, which I think might be more generalizable. The hardest thing to achieve in education is real transformational change, which is made up of incremental change. So the only thing that any of us can do is incremental change. Just doesn't work to pretend that we can make revolutionary transformations in our own classrooms. We can't. Not least because we have governments and inspectors and tests and examinations and so on, but that's only the part of the story. The real truth is that we are only atoms in this huge chemical equation. And even if we atoms get together and form molecules, we have a very hard time making a really... I don't know how I saddled myself with this metaphor. But anyway, as individuals, the revolutionary transformational change we can make is extremely limited. What I like about this project is that it shows... you could imagine a teacher saying, I just want to enhance my teaching of my second-year undergraduates in this subject a little bit using technology. Let me use this technology to help me do that. And then next time when I'm teaching this class, or I'm teaching another class, the system knows what it was that I thought was interesting, knows that I've taken a step in the right direction, and can come back and give me a little bit more. And I think this could end up, I'm not just talking about this particular project now, this could end up being something really powerful for us all in learning and teaching situations. That we might begin to use systems that become sensitive to our needs as teachers and to lead us a little bit more gently but firmly in the direction of not just evolutionary transformation but revolutionary transformation. Let me just... this is an example of a project. It's called the Haptel project, based in London. Not in my lab, but down the road at King's College, which is one of the colleges at London University. And this is doing something which is relatively straightforward these days. This is a project in the dental school. I noticed that there's a representative of the dental school in Hong Kong University here. I don't know who it is, but I know you exist. It's an example of, I'm sure you'll have seen several examples, using haptic devices to simulate the actual situation that a dentist would be in. And you can think of thousands of examples where that kind of device could be really helpful in learning this kind of activity, or all sorts of activities that we haven't really thought of yet. But, and of course, if it could work well, and there are lots of examples around the world where this kind of approach is being used, and it is extremely productive and a lot less painful if you have a dentist practicing on a technology-based system than your own teeth. But there is an issue that arises, and that is, I think it's true that transfer as a psychological phenomenon is the most researched issue of 100 years of educational research. So when the student is learning X, and you go to a lot of trouble for the student to learn X, sorry, X is not supposed to be about algebra here, then what are the other things, Y, Z, and A, and B, and C, that you might expect the student to know because they learned X? And the answer in educational research and psychology research over the last 100 years has been very, very disappointing. The short answer is not much. We spend a lot of time teaching people things that we think are going to prepare them for completely new contexts, and they don't. And this is a long story all to do with the nature, I think, of learning itself and what the human mind thinks of as learning. But we have to address this question. We cannot assume that people only know what it is we tell them, because we know that's not true either. People do become creative, and they do become innovative, and they do generalize from what it is they've been taught. But not necessarily automatically, and not everybody is able to do that.